My name is Jaime Fernandez from Mexico. My PhD is mainly about moving object path prediction for advanced driver assistance systems. Well, in this, well, I am from Mexico, and my main experience is around the area of computer science, from information technology to artificial intelligence. I studied my bachelor degree in the Instituto Tecnológico de Comitán in Mexico, where I mainly took courses about information technology, and of course about math, statistics, programming, web development, and things like that. But one of the modules that really got my attention was one about artificial intelligence indeed. And so at the end of my bachelor degree, I decided to apply for a master degree in a research center. The name is Centro Nacional de Investigación y Desarrollo Tecnológico, also in Mexico. So there I got accepted in the area of robotic vision with artificial intelligence. So the main courses there was about machine learning and computer vision. Once I finished there, I worked in an institute. The name was Instituto Nacional de Electricidad y Energías Limpias. But there I was not applying really my knowledge about computer vision and stuff like that. So at the end of that, I decided to move to Dublin in order to improve my English. And I took a course here for 6 months. So somehow, in the second month here, I got an internship in the National Digital Research Center, which is well known, in a startup. I was really happy there because I was applying most of the knowledge about machine learning, artificial intelligence, and things like that. So in one of our chat with my boss, at that time, I told him about studying a PhD in the near future. So in the end, when I finished my internship there, he told me about the Insight Center for Data Analytics here in Dublin City University. So I followed all the steps he told me to do, and I contacted Dr. Susan Little and Professor Noel O'Connor. So they invited me to work in a project as a PhD student here. Outside of my PhD, I am interested, for example, in developing technology for blind people. Most of the technology we have in computer vision can also be applied in this area, and it's going to be released. Maybe we should develop some hardware for that. And finally, outside of the academic area, I am interested in music. I love playing the guitar. Here in Dublin, once I played in a pub, was really nice, but a bit scary. So
now tell me a bit about your research.
okay. Now I am like in my final year of my research. So the name till now is Moving Object Path Prediction for Advanced Driver Assistance Systems. In this PhD, we decided to tackle the problem of predicting the possible future position of objects normally presented in traffic sense. For example, pedestrians, vehicles, cyclists. In short, what we do here is to predict where an object will be located in the future, okay? So we are mainly focused on the context of moving vehicles, but recently we are also working with surveillance cameras and predicting also in that context. What is the difference between this? When you are in a vehicle, the vehicle is moving and the camera is also moving, which is a challenge. However, when you have a surveillance camera, you are looking like from the top, and also you can predict by analyzing the trajectories of the objects on the scene. So what I am doing here, all the things I am doing here is based in one hypothesis that I have, which is a holistic approach is required to improve path prediction accuracy. By holistic, I mean an approach that takes into account several features from the object and the sense. For example, the type of object, the path position of the object, the region where the object is located, and maybe the post, and also maybe some roadmap that could be improved, the path prediction task. So in order to answer this hypothesis, I am mainly doing two activities. The first one is to explore how the observed trajectories can be better represented. By this, I mean to find what other features beside the X and Y position of the object can be used. Also, I am trying to find a proper representation of these features, how to use these features and how to put it in a data. Currently, I am representing the position of object as time series. An object travels a given space in a time-ordered manner. So one of the features of time series is that that there is an order in time. So I am using that. And the second activity is to explore approach that allows for processing this type of information, sequential information. So for this activity, I am exploring several methodologies. One well-known is the Kalman filter, the famous Kalman filter. The other one are some clustering techniques. And currently, I am mainly working with LSTMs, that stand for long short-term memories architectures, which is a special type of recurrent neural network. This type of networks allows for processing sequential data. And I hope that at the end of my research, I can make a good contribution for LSTMs. Finally, I would like to mention the problems I have had that mainly is about the data that is available on the literature. Because I want to use several features that more than X and Y positions, most of the data sets there in the literature only provide this information, so which is a problem for me.
We just asked them, what would you imagine then would be like a real-world application of your work?
Okay, we all know about all the severity of traffic accidents, how fatal can that be, okay? We know that the main factor for this is that the driver gets distracted for, like, looking at the phone, chatting with the other person, or maybe because he's very tired. So the main motivation behind this research is that accidents can be avoided or mitigated at least by reacting seconds in advance. And well, this can be achieved by predicting the future position that are moving around these vehicles. So that is why this research is important. For example, if you speak about real-world applications, one important aspect to mention about this research is that this PhD work is linked to a bigger project named VIDAS, which stands for Vision Inspired Driver Assistance Systems, which is an European project. We have several partners such as Honda, Intel, IBM, Bcontech, so just to mention some. So this means that all the work done in this PhD is applied to that project and to the real world of instrumented vehicles, and mainly to vehicles on the road. Beside the areas of instrumented vehicles, this research can also be applied, for example, to security monitoring systems in the prediction of trajectories. Here, it can be used, for example, to predict the trajectory of a people in a given scenario, and alert when a person is trying to reach, for example, a dangerous area. So, for example, in a metro station, when a person is trying to reach the train rails. Another application that I am really interested is in assistive technologies. I am very interested in this application. One good example could be in helping blind people to avoid collisions and walk in a naturalistic manner. With this research, we can alert to a person about the future position of objects around, and this way this person can be more confident when walking. Finally, I just want to add that the impact of this research is mainly to avoid or mitigate accidents caused by collision of objects.